dear students, we are on the CEC Gurukul lecture. We are in the series of the electronic circuit and we are discussing the various components used in development of the electronic circuit. In the today's lecture, we discuss one of the important component which is used in the electronic gadget, that is the rheostat. So, today we will discuss what is the rheostat, how we use it, how many types of rheostats are, then we will discuss in this lecture. Now, what is a rheostat? Rheostat basically a variable resistor which is used to control the flow of electric current by manually increasing or decreasing the resistance. It means it control the flow of electric current by controlling the resistance. So, rheostat is a variable resistor. It is given by the Sir Charles Wheatstone, coined the word rheostat, and it is derived from the Greek word that is rheo and statics, which means stream controlling devices or a current controlling devices. The main function of the rheostat is to control the current by changing its resistance. The electric current flowing through an electric circuit is determined by the two factors. First is amount of the voltage applied, and second is the total resistance of the electrical circuit. So, a rheostat will use to control the resistance. Then if we reduce the circuit resistance, the flow of electric current through the circuit will be increased. On the other hand, if we increase the circuit resistance, the flow of electric current through the circuit will decrease. It means it works proportionally. That indicates that this indicates that the rheostat used to control the current by changing the resistance. Now, by placing the rheostat in the electrical circuit, we can control, increase or decrease the flow of electric current in the circuit. Rheostat reduces the electric current flow to a certain level. However, it does not completely blocks the electric current flow, but it can decrease or increase or can adjust the electric current in a circuit. So, to completely block the electric current flow, we need infinite resistance that will block the electric current. If we use the infinite resistance, it will block the electric current. Practically, it is not possible to completely block the electric current. Now, you see on the screen, this is the construction of the rheostat. Here we are having 3 terminals A, B and C, and one is the wiper that move across the track. Now, the parabolic side is the track and one is wiper that move in the track, and we are having a 3 terminal, that is A, B, C. So, the rheostat similar to the potentiometer, and like the potentiometer, rheostat also consists of the 3 terminals A, B and C. However, we use only the 2 terminals, that is A and B or B and C. Terminal A and terminal C are the 2 fixed terminal connecting. You see on the screen that right hand the 2 terminal A, then the C, which are connected with the track, the fixed terminal, but this B terminal, which is connected with the wiper, will move. So, with the A and the C terminal are the 2 fixed terminals connected to the both the ends of the resistive element, which is called a track, and the terminal B is the variable terminal that is connected with the sliding wiper or the slider that move on the track, which is the resistive element. Now, the wiper that moves along the resistive element varies the resistance of the rheostat. By moving this wiper on the track, it will adjust it will change the resistance, and that adjusts the rheostat, and the resistance of the rheostat is changed when the slider or the wiper is moved over the resistive path. So, the resistive element of the rheostat is made of a coil of wire or the thin carbon film on which the wiper move. So, rheostat are mostly wire wound, and hence rheostat are also sometimes referred as a variable wire wound resistors, and generally rheostat are made by winding the nichrome wire around an insulating ceramic core. This ceramic core of the rheostat acts as a insulating material to the heat, and hence the ceramic core does not allow the heat to pass through it. So this is made with the wire and the ceramic material. Now you see, this is the symbol of the rheostat. In the American standard we represented like that, and in the international standard we represent by the box and the arrow. An arrow which represent the variable resistance. So rheostat, we represent the rheostat by these symbols. The zigzag line of the three terminals represent the American standard of the rheostat, and the rectangle box with the three terminal represent the international standard symbol of the rheostat. Now next, what is the working principle of the rheostat? Rheostat working principle is based upon the Ohm's law. As we know that from the Ohm's law, we can easily understand the resistance is inversely proportional to the electric current. As we see that if we increase the rheostat value, then the electric current will decrease, and it is inversely proportional to. It means that the resistance is increased, the current decreases, and hence it is vice versa. According to this, we can understand the resistance is also directly proportional to the length of the wire which we are using. Means we are taking the all the value of the track, and thus the resistance is increased as the length of the wire increases, which is if the number of the turns is increased, then the length of the wire will also increase. So resistance rheostat depends on the length of the resistive track as well as is inversely proportional to the current. So resistance of the rheostat depends upon the length of the resistive track through which the electric current is flowing. You are seeing on the screen that here we are having the left hand side, there is a current in, that is represented by the node A, and C, that is the coil of the wire that is around the ceramic arrangement, and right hand side we have having the ground out, then current out, and you can see here there is a wiper which is above the coil of the wire, and then electric current that will adjust the electric current by moving this wiper. So this is the basic arrangement of the rheostat. So resistance of the rheostat depends upon also the length of the resistive track through which the electric current is flowing. If we use a terminal A and B in the rheostat, the minimum resistance is achieved when we move the slider or the wiper close to the terminal A. It means when we put it on the left hand side, then the minimum resistance we are having. As we move towards the right hand side towards the C, we can get the more resistance, and the because the length of the resistive path decreases as we keep it near to the A. So length is in this case length is less, so the length of the resistive path decreases. As a result, only a small amount of the electric current is blocked and large amount of electric current is allowed. Now you see here we see that if the resistance is less, then the length is less, but the current value is high. So a large amount of current will flow in the circuit when the length is less as well as when the resistance is less. So in the similar way, the maximum resistance is achieved when we move the slider closer to the terminal C, because the length of the resistive path increases. As a result, large amount of the electric current is blocked and only a small amount of electric current is allowed to flow. So this is a very basic operation of the rheostat. And if we use the terminal B and C, you see on right hand side, if you use these terminals, the minimum resistance is achieved when we move the slider or the wiper close to the terminal C, because the length of the resistive path decreases. As a result, only the small amount of the current is blocked and large amount of the electric current is allowed. In the similar way, the maximum resistance is achieved when we move the slider close to the terminal A, because the length of the resistive path increases. As a result, large amount of electric current is blocked. Only a small amount of electric current is allowed. Now, we are not reducing the resistance of the wire or the resistive path. Instead, we are just reducing the length of the resistive path to decrease the resistance. On the basis of path, on the basis of distance or the length, we can define the resistance. We can decrease the, by reducing the length, we can decrease the resistance. When we turn the outside knob with other our hands, the wiper or the slider moves along the resistive path. Now you see, this is the, generally you have seen in your laboratories that this type of rheostat we use just to as we perform the many experiment, like to know the unknown resistance, to know the high resistance, to know the low resistance in the Wheatstone bridge, we use the rheostat, this type of rheostat in the laboratory. Now here it is having 3 terminals. You see, terminal A, terminal B, terminal C is there, and the coil wire is there, and this the above we are having the slider. This slider contact move left hand side and right hand side, which control the resistance, and on the basis of that we can block and flow of the current in the circuit. Now, how does a rheostat work? This is another question. As we know that this is based upon the Ohm's law. V is equal to IR, that we know that V is the voltage, I is the current, and R is the resistance. So, we want to alter the amount of current flowing across a circuit. We have the 2 options. What 2 options we have? We can change either the resistance on the circuit or the voltage applied to the circuit. By using this, we can change the flow of current in a circuit. As we know, V is equal to IR, as V directly proportional to I, and as we know through the Ohm's law. But here strictly V is equal to IR is the formula for definition of the electric resistance. Although for most practical purposes this is functionally interchangeable with the Ohm's law proper. It should be noted that a rheostat does not change voltage directly. The applied voltage remains constant across both the component and the circuit, unlike in the potentiometer. So, instead a rheostat adjusts current and thus the effect of the voltage by increasing or decreasing the resistance. Precisely how it does this will depend on the type of rheostat resistor being used. So, different rheostat have varying maximum power and resistance rating stating in watts and the ohms respectively. So, a linear rheostat, if we take an example, changes the resistance by dragging a sliding wiper that is in contact with a straight wire coil, and meanwhile controlling the resistance using a rotary rheostat involves turning a knob or dial to sweep the wire around a U-shaped wire coil. As you see, if we have a linear rheostat, then in the laboratory we use, then it will move like a slider. If we have a U-type, then it will work as a rotary rheostat and it will move in the round direction. Other basic rheostat types are used similar but slightly different method, and it will move as the path of the track is being developed. So, how do rheostats work? It is important to understand how to wire a rheostat circuit. So, wiring in the rheostat circuit is very important, which control the resistance, then we can control the current, block and flow of the current in a circuit. We need to highlight the role of the terminal and the connection on the rheostat. Firstly, we have the potentiometer uses the 3 terminals, one at each fixed end and third connection at the slider contact that is connected with the wiper. Number 2, a rheostat uses just 2 active terminals, one of which is fixed to either fixed and the other can be left alone or the grounded, while the second terminal is connected to the wiper. So it works in the two terminals. So such as potentiometer can be made to function as a rheostat by disconnecting one of the fixed terminal. A rheostat, however, cannot be made into a potentiometer by reversing the process. As a rheostat is connected via one fixed terminal and one sliding contact, the active length between these two connections can be altered when the wiper is moved along a wire coil. So the path taken by the electricity bridging these connections is therefore either elongated or the shortened. So in simple terms, we can say this mechanical length adjustment is what creates the variable resistance on the circuit. So wiring plays an important role which enabling the rheostat to alter and control the flow of current from the one terminal to the another terminal. So this is the basic important thing that is used in the rheostat development, which is the length of the coil. So what type of rheostats are? We discuss the types of the rheostat. So we need to mention the various key types and style of variable resistor, that is the rheostat. All do essentially the same thing, but their physical layout and the ideal uses are totally different. Like first we discuss the linear rheostat. How many types of rheostat? We will discuss one by one. First we discuss the linear rheostat. What is the linear rheostat? As we used in the laboratories, it is a linear rheostat with a two terminal variable resistance in which the sliding contact or the wiper is attached to the wire coil running in the straight line along an insulating cylinder. The mechanical operation of the linear rheostat thus takes the form of the two-way slide, and they are often called the slide rheostat or the sliding rheostats because it slide on the linear path. Moving the wiper in the one direction lengthens the electricity journey across the register. So by forcing it along more the wire coil due to the position of the sliding contact, this decreases the current flow, and moving it in the opposite direction shortens the path and lowering the resistance and increasing the current. Right now we can easily understand that larger the path and larger the resistance and the decrease in the current. But similarly we have that the larger the direction of the path, larger the resistance and the decreasing in the current. And the opposite, we can have the shorten the path, lowering the resistance and increasing the current. So it works in vice versa. You see that this is a linear rheostat. Linear rheostats are often used in the laboratories and testing environments, especially to run the different current across a circuit and check for the stability. This is the linear rheostats. Next rheostat is the rotary rheostat. What is as the name suggests, then it is having a rotary path. So a rotary rheostat works similar to a linear version, except the resistive wire coil is arranged in a horseshoe manner or the U shape. So and the contact wiper is connected via a turning dial or the knob. The basic operation principle is much same in both the cases. Like for the rotary rheostat, turning the dial in either drags pulls the wiper back and forth around the coil of the wire, and it is in the contact with, and this either extend or shorten the length of the resistive wire sitting between the fixed and the sliding terminal. So current is affected in an inverse relationship with the length of the wire exposed. A shorter path provides the decreased resistance and thus higher current. while a longer path increases the resistance for the lower current. You see on the screen, and it will move in the uh, round path. So this is the rotary rheostat. Next is ohmite rheostat. What is this? It's a leading brand name of the rheostat and variable resistor in the market, and that are often preferred for their robust wire mount design. Multiple shaft designers and adjustment arm technology used in this type of the rheostat, and the engineering strength result in the widely used rheostat in the high power motors and the current control applications, practically where the live circuit control is needed, where we use this type of rheostat. So ohm meter rheostats benefit from a UL rating with the 11 standard size and range of the flexible configuration, making them a versatile choice for the circuit control in situation where the live current flowing during the adjustment. So you are seeing on the screen that there is a knob. By moving this knob, we can adjust the resistance, and you see on the base of it there is a 2 terminal, right. So next type of rheostat is the plug-in rheostat. Plug-in, this is like the external rheostat which we can attach to the certain appliances of the circuit as the aftermarket addition, means that can be plug in any device. So the aim is usually to give the device a range of adjustable power setting when it does not have the function built into its core circuit. Then we can use this plug-in rheostat as an external device. So common examples include the lamps, fan, blowers, plug-in rheostat used, and plug-in rheostats are often sold as a plug-in dimmers, which when they are intended for function other than adjusting a light source. Next type of rheostat is the preset rheostat, and these are the rheostat that are used in a printed electrical circuit board as a trimmers, and as a preset rheostat they are used, and they are very small type of rheostat. These are also called a trimmers. Trimmers are also called a very they are very small type of rheostat which is mostly used in the calibration circuits. And the preset, the 2 terminal trimmers are usable, although most of the time 3 terminals are used. Potentiometers trimmers are used as a rheostat of the 2 terminals. You see there are the 2 terminals. You can see this is the preset rheostat. Now what are the application of the rheostat? Rheostat is generally used in the application where the high voltage or the current is required, where we use this rheostat. And the rheostat are used in dim lights to charge the intensity of the light. If we increase the resistance of the rheostat, the flow of the electric current through the light lamp decreases. As a result, the light brightness decreases in the similar way. We decrease the resistance of the rheostat, the flow of the electric current through the light bulb increases. As a result, light brightness increases. Rheostat are used to increase and decrease the volume of the radio, or to increase or decrease the speed of an electric motor, and these are used to control the amount of voltage or current flowing across the electrical circuit. It is a variable resistance such as a rheostat or a potentiometer can easily altered by the user. The basic function of rheostat in the circuit is to adjust the amount of current flow required. So by further most application, power control devices use this rheostat, and this covers the brand range of the potential rules and the functions. Rheostat can be used as a dimmer for the electric lights, and they are used in the many modern circuit being designed with the high speed electronic switching functions to control adjustment of the current. Rheostat are still widely used in the specialized role in the circuit tuning and calibration. So thank you very much. We will discuss further with regarding the rheostat. Thank you.